longer the same. Can we, don't draw anything on your paper right now, can we add 1/2 plus 1/3?
No.
Why not? Mackenzie. Why can we not add these right now? Chris? Okay. Anushka?
Because one is 1/2 and one is 1/3, and so you're not supposed to add those numbers together, or else you're gonna get an unequal number, or that they don't have the same number of pieces.
Right, because they're broken down into different sizes, right? 1/2 is very different from 1/3. You cannot add these together. This is not equal to 2/5, right? It's not, when you add these two things,
But it's not.
1, 2, 3, 4, 5, it does not become 2/5, okay? We need to create what? What do we need to have the same in order to add these? Jillian?
We need to create an equivalent fraction that has the same.
Okay, we might need to create equivalent fractions because in order to add, what's that? Not right now, because I need you to see this model, okay? What do we need to create in order to be able to add fractions, James?
We need to, the bottom has to be the same.
What do we call that? What's the bottom?
Denominator.
The denominator, we need a common denominator, okay? So we are going to use a rectangular fraction model to find the sum.
What does that mean?
So how do you think we can add these? Does anyone think they might know how we can add these using a rectangular fraction model? James?
Can I draw it on the board?
No, I just want you to just tell me what we're doing for now.
So, draw the rectangle.
Okay. Don't write anything on your
Then
papers
you're
yet.
going to do a half down.
Okay.
Or, then you're going to do two lines. Horizontal.
Get it.
Okay, so I don't want to jump and put that into this one right here. Can I make another fraction?
Yeah.
Okay, so draw another rectangular fraction. So right now, James said, let's represent 1/2. Why am I putting this 1 up here?
Because that's
Why am I putting this 1 right here? Julia?
Because you shaded in line.
Not because I shaded in 1. I only shaded in this part right here. Yeah?
Because it's one box. Because it's equal to 1 half.
Right, because it's one whole, right? So I'm drawing this to represent one whole, and then I'm drawing this to represent 1/2, okay? So far we represented our fraction of 1/2. And James, what else would you like to represent?
In the next one you draw a half to it, so 2/4.
Okay, well we've already represented our half, so I don't want to draw a half again.
Okay, so
What else do you think we now need to represent?
we need to represent,
Chris?
you need to represent 1/3.
1/3. How would you like to represent 1/3? How would you like to represent 1/3, Jillian?
Make 2 lines going down.
2 lines vertically? Like this?
Yeah. No. No.
So this might make it challenging to find an equivalent fraction. James, what do you think?
Draw 2 lines going horizontal.
So James says, let's draw 2 lines going. Horizontally.
And then draw a half.
All right, 1 second, James.
And then just draw a line down. Going down.
So again, I'm going to represent this as one whole, and I'm going to represent this little piece here as 1/3. So far, 1 second.
I really don't get this.
So far, all you need to see is that we are representing 1/2 right here, vertically, and we are also representing 1/3 horizontally. Okay, but remember, to get a common denominator, what are we going to have to do to get a common denominator? How are we going to change this fraction? What do we want to do with this fraction? What do we want to do with this fraction? Anushka?
You want to make it into 6. You want to make the denominator into 6.
Okay, well, we might not end up making it into 6 in this picture. But what do we need to get?
We need to get the 1/3 to a 1/2.
We don't necessarily need it to become 1/2.
We need to add.
But we said we needed to get what kind of denominator?
We need to have the denominator equal.
Brady says a common denominator. So we know that halves are not going to work. So what type of fraction am I going to need to create? No, I don't want to know what the denominator is going to be. I just need to know, what are we going to do? What have we learned to do when we partitioned? What kind of fractions are we making?
We're making
Equivalent fractions. So we want to turn these into some type of equivalent fraction. Now, James, you were talking about something with carrying some lines over.
So draw one line going down and up the second one.
So James notices, guys, let me draw this up here for 1 second. So James notices this vertical line here in the first fraction. We're going to copy this vertical line over here.
And then we're going to shade in this right now.
We're not going to shade in anything yet. So we copied this vertical line over here. What can we do with these horizontal lines? Madison?
You bring them over to the one with the vertical line.
We're going to bring those over here. We now made two equivalent fractions. Spencer, is this fraction equivalent to 1/2?
Yeah.
Yes. Is this fraction still equivalent to 1/3?
Yeah.
Do they have the same number of parts?
Yes.
Yeah.
Aren't they both out of 6 parts?
Yeah.
Do we have a common denominator now?
Yeah.
Shading.
So what is the equivalent fraction for 1/2? Jillian?
3/6.
1, 2, 3 out of 1, 2, 3, 4, 5, 6. So 3/6 plus what is the equivalent fraction for this right here? James?
It would be 2/6.
2 out of 6. So 2.
And that would equal 5/6.
And when you add these together, now we know that we can just add our numerators. 3 plus 2 is 5, 6. So now you may copy this one down onto your paper.
Does anyone else get this, or am I the only one not understanding?
Yeah, I understand it.
We'll do another one.
Can I do the next